Right now, the National Weather Desk, flash flooding takes center stage this morning. We'll look into the root causes.
This increase in humidity, paired with hot summer temperatures, will fuel daily showers and thunderstorms.
The role climate change could be playing.
It's clearly shown in the last several years that we are not prepared for the extreme weather of today.
How topography in the Texas Hill Country contributed to this month's deadly flooding.
The soil is very shallow, just a couple inches deep, and beneath that is bedrock.
As more communities call for river gauges, we'll take a closer look at how they can offer an early warning.
From our nation's capital, this is the National Weather Desk.
Good morning and welcome to the National Weather Desk. I'm Angela Brown. From Texas to the Northeast, this has unfortunately been the summer of flash flooding. This morning, our team of meteorologists is taking a closer look at flooding, the causes, and what we can do to stay safe. We want to start with meteorologist Jennifer Collins, who explains why summer is the season for flash flooding.
Well, as we transition from the late spring into early summer, we're no longer influenced by the polar jet stream or strong upper-level winds, which helps to steer systems west to east across the United States during the winter months. Low-pressure systems and cold fronts associated with the polar jet tend to move moisture quickly, and storms don't last very long. But during the summer, as the polar jet stream moves north, the United States is now influenced by the Bermuda High, or an area of high pressure that sets up in the subtropical Atlantic, and is known to steer tropical systems during hurricane season. Clockwise flow around the Bermuda High draws tropical moisture in from the Caribbean and the Gulf into the southern United States. This increase in humidity, paired with hot summer temperatures, will fuel daily showers and thunderstorms. Storms during the summer are not steered by any jet system and are instead steered by weaker sea and land breezes. This means that storms are slow moving and produce more rain in a short amount of time. Warmer air will also hold more moisture compared to colder air, which is why summer storms have higher rain rates. When a storm produces rain over the same amount of area for an extended amount of time, the ground can no longer absorb it, and this can cause flooding. It's important to know the difference between flood alerts. A flood watch means conditions are favorable for flooding, so be prepared. A flood advisory means flooding's not expected to be bad enough to issue a warning, but it may cause significant inconvenience. A flood warning, it means flooding is happening or about to happen, so you should take action. And a flash flood is the sudden rush of water after a heavy rain event or a dam break. And at this point, you need to seek higher ground immediately. Avoid floodwaters and never drive or walk through flooded areas, as even a small amount of water can sweep you away. If you encounter floodwater, turn around, don't drown, and seek a different path.
And according to the National Weather Service, flash floods are the nation's #1 storm-related killer. And as Gracie Palmer explains, they are becoming more frequent while growing in intensity.
According to Climate Central, rainfall rates today are now 15% higher than in 1970.
That's not taking into account climate change, where these events are starting to happen more frequently.
And in areas where we wouldn't expect flooding.
So the same rainfall event today will have more moisture to work with and cause more rain than it would have 50 or 100 years ago.
Scientists claim climate change is one of the main causes.
A warmer atmosphere holds more moisture in it.
As the planet warms, storms get stronger and rain gets heavier. Climate Central reported that for every 1 degree of warming, the air can hold 4% more moisture, leading to heavier downfalls. WLOS meteorologist Jason Boyer says the landscapes of certain areas can also play a role. He breaks down the difference between the flooding in Texas and Helene.
Now, with our rainfall, we were able to push it down into several different river stems and kind of flush it. Even though we had flash flooding, it could have been much worse if there was only maybe 1 or 2 main stems. Like over here in Texas, it's the Guadalupe and the Colorado River. Those are really the 2 big ones.
It's going to rain. But I think it's clearly shown in the last several years that we are not prepared for the extreme weather of today, let alone how that extreme weather is going to change in the future due to climate change.
Scientists say in order to better prepare, people must be educated on the dangers of living by a river and listen to warnings when they are presented.
We ask people to have multiple ways of getting warnings. Don't just rely on your cell phone, a weather app. Have radio, a weather radio from NOAA.
The record rainfall was a root cause of the deadly floods in Texas, but the unique topography of the region also played a role in creating the floods. Austin meteorologist Avery Tomasco has more.
But it rained in the part of the world known affectionately, or not so much in this case, as Flash Flood Alley. We are at the intersection here in Texas of Gulf moisture and Pacific moisture. We had both of those things this weekend. More importantly, when the heavy rain fell, and it was especially heavy because of all that moisture, had to deal with the topography out here in the hill country. The soil is very shallow, just a couple inches deep, and beneath that is bedrock. So when the soil soaks up, all that runoff runs downhill, and these are steep hills, especially along the Guadalupe, which means that the river rose as quickly as it did and to record levels. The fact that we are in Flash Flood Alley, by the way, is the reason why the Highland Lakes came to be. Where Tom Miller Dam is, were two previous dams, both known as Austin Dam. Both were washed out by floods, catastrophic, way back in the day. So it was decided that we needed to control the flooding better. Lake Travis and Lake Buchanan constructed to do just that. When they are really low, they can hold a lot of water.
By now, you've no doubt heard the Guadalupe River did not have warning sirens to alert people to the rising water. On a recent episode of our podcast, Off the Radar, meteorologists Emily Gracie and Matt Ritter spoke with the National Weather Service hydrologists about the process of measuring river heights.
A river stage is we're just measuring how much water is in the river from, this is where it kind of gets confusing, an arbitrary point. They're not related to sea level. So, you know, some may say that you're saying there's only 40 feet of water in the river at point A and only 20 feet of water in the river at point B. And it's kind of arbitrary. So you kind of got to get that out of your head.
Right. And to not to lead your comment, but a lot of folks, including some meteorologists, think a river stage is a river depth, and that's not necessarily true.
That's
right?
absolutely right. That's a great way of explaining it. It's not the depth of the river, because you could have a river stage of 17 feet, but there's only 4 feet of water in the in the river.
So I'm curious about the gauges themselves. How are you guys in charge of setting those up, and who does that, and how is it decided where they go?
I'm glad you mentioned that, because we could not do what we do without the USGS, U.S. Geological Survey. They put out all the gauges, they maintain them, and they're fabulous. And they have a variety of different gauges. They have a float gauge that they run a wire down and they put like an upside down pie plate in there, and it floats up and down. It's on a pulley system, and it's got a counterweight. And when the water goes out, up the pie plate raises and the counterweight goes down. And they can measure the length of the wire, and it's got a satellite linked to it. And once an hour, it'll send that number up to the satellite. The satellite takes it and relays it to our receiving station in Wallops Island, and then from Wallops Island, it comes to our office.
And you can hear much more from this interview by downloading Off the Radar wherever you get your podcasts. This episode is called Stage Fright, Decoding River Floods. This week's episode looks specifically at the Texas floods. Here's Emily again with a preview.
On July 4th, as communities across America celebrated the national holiday, the Texas Hill Country faced an unimaginable tragedy. Flash flooding claimed lives and forever changed families. The numbers tell part of the story, but they don't tell us how to prevent this from happening again. They don't tell us how to build better warning systems, stronger communities, or more resilient responses to extreme weather.
Flooding is it's a complicated thing. We don't observe the water on the landscape very well. It's really important for us to think about those things as we think about our alerting systems and what it takes to make them effective.
This week, we're going off the radar with Dr. Kim Clocko-McLean to focus on what comes next.
We have to walk through the really painful things to make sure that we learn and that it doesn't happen again.
How do we turn tragedy into understanding? How do we transform loss into action? And how do we help communities heal while building a better future?
It's been a hard year for the weather enterprise. It's been a hard year for the Weather Service in particular. I think we're about to see it get put back together.
And coming up on the National Weather Desk, a closer look at the devastating and often deadly impacts of storm surge, plus the localized and damaging downdraft of air known as microburst.
You are watching the National Weather Desk.
Storm surge creates a different kind of flooding. It's not caused by excessive rainfall, but by tropical or hurricane-force winds blowing coastal water onto land. The results are often devastating and also deadly. Meteorologist John Gum shows us how it happens.
Well, it's that push of water that comes in advance of the hurricane and as the hurricane makes landfall. You think of the winds out ahead of this thing blowing that water toward the coast, and that water piles up. The stronger the hurricane, the stronger the storm surge can be. So let's take a 3-foot storm surge, for instance, here. That comes up to the dune line along many beaches, may cause damage to the beaches. But when you start to get into the higher storm surge, maybe a storm surge of around 6 feet, which is going to be pretty common, it looks like, into the Tampa Bay area, that's when you start seeing flooding of homes adjacent to the water, adjacent to the coast here, especially on the first floor. The 12-foot storm surge not just inundates the lower levels of structures adjacent to the coast, it can inundate the upper floors, the second floor of these structures. And this storm surge is the most deadly part of a hurricane. It kills more people than any other aspect of the storm.
Well, severe summer storms can often include microbursts. They can cause extensive damage and even be life-threatening. Montana meteorologist Mitchell Combs takes a closer look.
As with all severe weather, we first need a thunderstorm to develop. These storms develop as air rises, cools, and condenses. As the storm continues to grow, it'll sometimes encounter a layer of dry air in the mid-levels. This dry air causes that rising air to cool even faster and become more dense in a process known as evaporative cooling. Dense air is more difficult for the updraft of the storm to keep aloft, and eventually it becomes so heavy it comes crashing to the surface. As this rapidly descending air reaches the surface, it must spread outward in a localized area. Microbursts often produce winds of 40 to 70 miles per hour, but the strongest of them can produce winds exceeding 100 miles per hour.
Another weather phenomenon in the summer is pop-up thunderstorms. How exactly do they form? Meteorologist Sharon Ray explains.
These are caused, of course, by warm, humid air, and in the summertime especially, as the sun is heating up the surface, that warm air continues to rise. Well, as it's rising and running into cooler air aloft, it can form those droplets and form clouds, those cumulus clouds that can develop. If the air motions do continue, those clouds can get taller and it can continue to build as the updraft strengthens in the cloud. And we start to see the potential for some rain. If there's enough moisture, you get those raindrops developing, and we end up with the rain coming down out of the cloud, bringing the cooler air aloft down to the ground with the downdraft. Now, this process can keep going as long as we have an updraft, but what often happens this time of year, because we don't usually have a lot of wind shear, that the thunderstorm is vertically developed, and the downdraft ends up dominating and ends up squashing, if you will, that updraft. So these are usually short-lived because the downdraft ends up squashing the updraft, the storm gradually dissipates. So storm formation needs 3 things, at least for storms to develop. Instability, that's cooling with height, the source of lift, such as the differential heating at the surface, or maybe a frontal boundary, or even converging air because of outflow boundaries. Moisture is needed as well, and that's water vapor, and we certainly have plenty of that in the atmosphere today. So for those summer pop-up storms, they are associated with the warm, humid air. Now, they're less likely to be severe, but sometimes they can produce some strong downbursts of wind and locally heavy rain.
Meteorologists often talk about rain chances during their forecast, so how do they come up with that percentage? Meteorologist Vitas Reed explains.
I'm meteorologist Vitas Reed. Want to tell you a little bit about percentages and rain chances. We talk about that often as far as a chance for rain, and what that actually means when we show those percentages is it means the area coverage that you may see some spotty showers or a lot of rain in your area. So as you can see, 20% chance means in that forecasted area there may be some spotty showers. Not everybody will see it, but it is a better chance you might see it. When you get to 30 or 40% chance, that means like scattered showers, 40 to 50%. But then you get to 60 to 70%. That's numerous areas getting showers or thunderstorms. And then you get widespread showers when you're in that higher percentage at 80 to 100%. That gives you a little outlook on when we're talking about percentages. Not everybody gets to see the rain, but many might see it depending on where you are and how much rain is coming down.
Well, have you ever heard of cloud iridescence? It's a rare sight, but pretty beautiful. Meteorologist Christian Bridges recently posted about them on TikTok.
Have you ever seen a cloud like this? We had a viewer in Westbrook, Maine who sent in this picture, and it's a really great example of cloud iridescence. This cloud iridescence forms when the sun shines through a high, thin cloud that has similar sized water droplets or ice crystals, and that light reflects and refracts off of those droplets or crystals, making this really beautiful rainbow effect. It's also very different from something that you may have seen called a sundog. Here's an example of what a sundog looks like. You can see it is a point of light that forms on either side of the sun, with the sunlight refracting off of ice crystals that tend to be a lot larger than the crystals or particles that we see with cloud iridescence. So while they are similar in some ways, cloud iridescence tends to be a lot more colorful and can form anywhere in the sky, whereas a sundog forms at those set points.
Be aware of ticks. That's the message from health experts following an increasing number of people getting sick from tick bites. Mike McCarthy has more from Ohio.
Megan Waterwash celebrated her mom's birthday with a short hike, not really concerned about what might crash the party.
I don't worry about it because I've never had a tick, so I think it is just part of life, but it's not on the front of my mind all the time.
But Ohio State tick expert Timothy McDermott says it should be for all of us. He says warmer weather has helped more species thrive and in more places, like the woods, but also on mowed grass.
The speed of change really has gone from 0 to 100 miles per hour in really just about the past 10 years.
It's certainly not pleasant when you remove one.
David Moritz has seen the change. He says he's found more ticks on his dog this year than ever before.
Luckily, Thorin has short hair, so it's pretty easy to catch them.
Data from the Ohio Department of Health shows tick-related diseases are increasing too. Last year, there were nearly 50 times more Lyme disease cases compared to 2010.
Is this a situation where more people are actually getting sick, or are we just getting better at tracking this?
So I think it's a little bit of both of those. More people are getting sick.
McDermott says to avoid ticks, stick to trails, wear long pants and shirts, also light colors so it's easier to spot bugs.
When it comes to using bug spray, McDermott says read the label to verify it is for ticks. Same goes with precautions for your pets. And if you do get one on you somewhere, the sooner you remove it, the better. If I do get a tick on me, what is the best way to get it off?
The easiest way to get a tick off, I like to use pointy tweezers or those tick tools. What you don't want to do is just try to grab it by its butt, because you'll probably yank its butt off. You'll probably squeeze the gut contents into you. That's going to increase the chances of you getting sick.
And time now for a short break, but first we soar over Florida's overseas highway.
You are watching the National Weather Desk.
This is the time of year when bats are most active, especially in Texas. And when they emerge from their caves, they eat an incredible number of bugs. Meteorologist Brad Schauder breaks down the numbers.
In South Texas, there are a lot of bats. In fact, so many you can see them on radar. These are all bats. Now, the world's largest colony of bats actually in South Texas. It's right near San Antonio, and it has 20 to 30 million bats. That colony, along with other local colonies in South Texas, eat a lot per night. A lot of bugs. Just how many? Well, they eat 120 billion insects in a single night, each night in South Texas alone. It's over 1 million pounds of bugs. Now, that amount would be enough to fill 2 school gymnasiums full of bugs every night. You only have to imagine how many more bugs would there be without bats. And apparently this will save farmers millions, if not billions, each year on pesticides.